You hear about AI and large language models all the time, right? They feel like this impenetrable black box, like some kind of magic. But today, we're going to pull back the curtain and really dig into what's going on under the hood. So let's get into it.
So here's the game plan. We're going to start with the surprisingly simple idea at the core of it all, the prediction game. Then we'll talk about the transformer revolution that honestly changed everything. We'll peek inside the secret sauce, the attention mechanism, then see how these models basically swallow the internet to learn. And finally, we'll get real about their incredible powers and their pretty serious pitfalls.
All right, so to kick things off, let's just start with the most basic, fundamental question of all.
I mean, when you see an AI write a whole paragraph, what is it actually doing? It looks like it's thinking, maybe even understanding, but really, behind all that complexity, it's just playing an incredibly sophisticated guessing game.
And that's it. Seriously, at its absolute core, a language model is just a probability engine. If you give it a sentence like, the cat sat on the, it looks at that sequence and calculates that the word mat has a super high probability of coming next, while a word like bookshelf is less likely, and elephant is, well, almost zero. Its entire existence is just making the best possible guess for the very next word over and over and over again.
But here's where things get really cool. It's not just what they predict, it's how. See, the old models were basically just fancy word counters, very rigid. Today's neural models are way smarter. They turn words into these complex mathematical objects called vectors. Think of it like a giant multi-dimensional map of ideas. On this map, words with similar meanings, like king and queen or walking and running, are neighbors. This lets the model grasp abstract concepts, not just stuff it's memorized.
And that new way of seeing words as points on a map, well, it paved the way for a massive breakthrough in 2017 that completely changed the AI world forever, the transformer.
Before the transformer, we had these models called RNNs, and they tried to read text just like a person does, one word at a time, in order. The problem? They had a terrible memory. Like, they'd get to the end of a long sentence and completely forget what the beginning was about. But in 2017, the transformer came along and solved this with a pretty radical idea.
And this right here, this is the light bulb moment. Instead of that slow, one word at a time slog, the transformer processes every single word in the text at the exact same time. This parallel processing is its superpower. It allows it to instantly draw connections between any two words, no matter how far apart they are. This is what makes modern AI so fast and so powerful.
Okay, so how in the world does a model look at everything at once without its brain just melting from confusion? Well, that's where we find the real secret ingredient. It's a brilliant mechanism called self-attention.
Just look at this sentence for a second. How do you know that the word it refers to the animal and not the street? Your brain just does it instantly. You don't even think about it. But for an AI, that's a really hard problem. It needs a mathematical way to figure out that when it's looking at the word it needs to pay more attention to the word animal.
So here's a simple way to think about how it works. For the word it, the model sends out a little search request, a query, that basically asks, hey, I'm a pronoun. Who am I referring to? In response, every other word in the sentence holds up a little sign, a key, that describes what it is. Animal holds up a sign that says, I'm a thing that can feel tired. Street holds up a sign that says, I'm a paved surface. I don't get tired. The model sees a super strong match between the query from it and the key from animal. So it gives that connection a high attention score and pulls in the value, the meaning, from that word.
And it gets even crazier. The model doesn't just do this once. It uses something called multi-head attention. You can picture this like having a whole team of specialists all reading the sentence at the same time. One expert is just looking at grammar, another is only focused on cause and effect, a third is tracking the relationship between people and objects. By layering all of these different perspectives together, the model builds this incredibly rich, multi-layered understanding of the text. So we have this absolutely brilliant architecture. But an architecture is just a blueprint, right? To turn that blueprint into an actual intelligence, you have to train it. And you have to train it on a scale that is just hard to even wrap your head around.
I mean, just to give you some perspective, a model like GPT-3 has 175 billion parameters. You can think of these as tiny little knobs and dials inside the network that get adjusted during training. It's a truly staggering number.
So the question is, how on earth do you tune 175 billion knobs to the right settings? You can't do it by hand, obviously. You need a simple task, something the model can do over and over, billions and trillions of times, to teach itself.
And that task is the exact same one we started with. Just predict the next word. During this phase, called pre-training, the model is basically force-fed a huge chunk of the internet. Books, Wikipedia, articles, you name it. And its only job for trillions of examples is to guess what word comes next. Now, to get good at such a simple game on such a massive scale, it has no choice but to learn everything else along the way. Grammar, facts, common sense, logic, and even different writing styles.
And this is exactly what happens every time you use a chatbot. It takes your prompt, predicts one single word, then it staples that word on the end of the prompt and treats that as a brand new input. Then it does it again and again. It's always moving forward one word at a time. And that, by the way, is why it can't go back and fix a mistake it made 3 sentences ago. For the model, that text is already part of the past.
So when you take this incredible architecture and you train it on a huge portion of human knowledge, you end up with some truly amazing and sometimes pretty concerning results.
Now, the really wild part is that as these models get bigger and bigger, they start doing things nobody ever explicitly programmed them to do. They're called emergent abilities. For instance, you can give a big model just 2 or 3 examples of a new task right there in the prompt, and it just learns how to do it instantly. Or you can tell it to think step by step, and suddenly it's able to break down a hard problem and reason its way to a correct answer. It's almost spooky.
But, and this is a huge but, for all that power, they come with some deep fundamental limitations. They hallucinate, meaning they'll just make stuff up with complete confidence, and it sounds totally plausible, but it's just wrong. Their knowledge is frozen in time. They know nothing about events that happened after their training data was collected. Their reasoning can be surprisingly brittle. They can write a beautiful essay but fail at simple math. And ultimately, they have no true understanding of the real world. Their entire universe is just text. And all of this leaves us with the central billion-dollar question that's driving AI research right now. We know for a fact that as we make these models bigger, new, almost magical abilities will continue to emerge. But we also know that new, more subtle, and perhaps more dangerous limitations will come along for the ride. And the real challenge for all of us is figuring out how to harness that incredible power while navigating those inherent flaws. Thanks for tuning in.